The Go Direct energy sensor makes it easy to measure energy output from classroom-scale renewable energy systems. Today we're going to measure how much energy we can capture from a wind turbine that's being blown by a standard household fan. Electrically, the connections are very simple. I just connect the red lead to the red wire and the black lead to the black wire. On the energy sensor, I just make sure I have my switch set to the internal load, which is the simplest setup. I'm going to power it up by pressing the power button. And as with all of our Go Direct products, you can connect it via USB or via Bluetooth. And it works with 5 different platforms: iOS, Mac, Windows, Android, and today we're going to use a Chromebook. So now that I've got it on, the red light next to the Bluetooth indicator is flashing, which means that it's advertising. So on my Chromebook, I've already got Graphical Analysis 4 open. So I'm just going to choose Sensor Data Collection. I'll see a list of all the available sensors, and then I choose my sensor from this list. Once I choose Connect, it establishes the connection via Bluetooth, and then I can see a list of all the channels that are available. The sensor measures voltage, current, power, resistance, and total energy. I'm going to go ahead and leave all of those on for now, so I'll just say done. And then I get a graph of both voltage and current versus time. So I'm going to start my fan, and then once my blades are spinning, I'm going to start data collection. So I just click Collect to start graphing in real time both the voltage and the current of my system. When the 30 seconds has elapsed, the software automatically zooms in to give me a better view of the data that I actually collected. In this case, the voltage and the current varied throughout the data collection run, which is standard with a small electrical motor. What I'm really interested in is how much energy was I able to capture in 30 seconds. So to find out, I just modify my lower graph. So I click the vertical axis label on my current graph, turn off the current, and turn on energy. So now I have a graph of energy versus time, and to get my total, all I need to do is select the last point of the graph and see what the value was for energy at the end of my 30-second trial. With 30-second trials, we can do lots of iterations within a class period. So the kids can investigate the effect of, for example, how many blades there are on this turbine, what the angle is of those blades, the length of the blades, the shape of the blades. We can do each of these separately. We could also look into gearing and look at the effect of different gear ratios on the output of a wind energy system. That's not the only source that we could use, though. We could also use a small solar panel. And in the case of solar panels, we could look at the effect of the angle of the solar panel relative to the sun, or adding more solar panels in series versus parallel and looking at how much energy we can collect from the solar panel in full sun. In this case, we use the internal fixed load, which is a very nice, simple setup, and that's actually what we use in the National KidWin Challenge, where the sensor is used quite a bit. We can also look at the external load. So rather than just the internal 30-ohm fixed load, we could connect external resistors to the connectors on the energy sensor. So in this case, I would just flip the switch over to the external load, and then using the tabs that are built into the sensor, I could connect to an external load. It could be a simple resistor, but it could also be something more interesting like a water pump or lights or buzzers, something that's going to do work that the kids can actually see in the classroom. So the energy sensor provides you lots of different ways to investigate all the different variables around capturing renewable energy. For more information, visit our website.